So what we want to do then is, again, we want to be able to simplify this rational expression, and we do that by factoring. So we're going to factor this. So this is a leading coefficient of 5x squared. So I'm going to use my diagonal product strategy. So I know that we're going to end up with 10x and 3x here. So my factors end up being 5x plus 3, and then x plus 2, which is a common factor vertically. So this becomes 5x plus 3, x plus 2, all divided by x plus 9, x plus 2. Okay, so we have to differentiate between this factor, which doesn't cancel, and we want to differentiate with these factors that do cancel. Okay, we have restricted values, x not equal to -2 and x not equal to -9. And two different things are going on at those points. Okay, so go ahead and graph that, and we're going to see what that looks like. Okay, so predict, what do you think is happening at -9 and what do you think is happening at -2? Okay, you don't have to really predict what the graph looks like, although I do want you to get familiar with what these rational functions do look like. So we need to be familiar with the shapes of these. So, as we stated before, when factors cancel, we get wholes. When the denominator doesn't cancel, we get a vertical asymptote. So what you should observe then is a vertical asymptote at -9. Okay, and again, I want you to be graphing these. You're going to get a horizontal asymptote. Oops, I think it's going to look more like this. Sorry. It's going to look like that. Okay, and look like that. So we're going to end up with a horizontal asymptote kind of up there. It's going to cross that. Well, the 0 portion can be found in the numerator here at -3/5. But basically, we can see that we get a hole at x equals -9. Okay, so at -2, okay, -2 is right about here. Okay, it's before I kind of maybe should adjust my scale a little bit. And I'm going to get my -2 somewhere around here. And that's going to generate a hole. So the factor that doesn't cancel gives me a vertical asymptote. The factor that cancels gives me a hole in the graph. So there's some terminology here that we need to be aware of. Asymptote is a value that the curve approaches but never touches. Okay? And we're just kind of focusing on the vertical asymptote. There are actually lines that don't exist, but the calculator sometimes will draw them in, sometimes doesn't. But they are asymptotes. Okay? They are lines, they are values that we approach that doesn't quite touch. So you wouldn't see this line on your graph, but you can see that there is a vertical line where this line just gets closer and closer to but doesn't touch. And those are asymptotes. And there are also horizontal asymptotes, but we're not going to worry about those at this point. What's happening at the restrictions? Okay, there's only two things that can happen. So when we have factors that don't cancel, there is this vertical asymptote. When you have factors that cancel, you have a hole. So this here we have at -3, we end up with a hole. At +2, we end up with a vertical asymptote. Okay, and so these are some generalizations that we can start making when we start dealing with these rational expressions. Again, I don't expect you to know what they look like now, but I want you to start getting familiar with the shapes that rational expressions can take on.